Picture the OSI model as a 7-layer cake, each tier with its distinct flavor. As a network engineer, this is your go-to guide. Knowing which protocols and devices fit into each layer is crucial, mostly because exam questions have a sneaky way of grilling you on this. So, let's dive into it. The OSI model is like your favorite 7-layer dip, but it's all about network communication. Starting at the bottom, we have layer 1, the physical layer. This is where the bits live, running through cables, signals, and voltage. It's the hardware side of data transmission, the nuts and bolts, if you will. Next up is layer 2, the data link layer. This is where frames are sent between directly connected nodes. It's the world of MAC addresses and switches, and it all revolves around Ethernet. Think of it as the mail sorting room, getting everything organized before it heads out. Climbing up to layer 3, the network layer, things start to get logical. Here we deal with IP packets and routers, like navigating a roadmap to find the best route. Then there's layer 4, the transport layer. This one's all about making sure your data travels smoothly from point A to point B, handling TCP, UDP, and those crucial port numbers. Like a delivery service ensuring your package arrives safely. At layer 5, the session layer acts like an event coordinator, managing sessions and keeping data flowing without a hitch. Layer 6, the presentation layer, takes care of encoding and encryption, making sure the data is formatted and secure before it's used. Finally, at the top is layer 7, the application layer. This is the layer you interact with directly. Think HTTP, DNS, and FTP. Just like reaching that delicious top layer of dip, the application layer is where everything comes together for the end user. Alright, let's talk about the OSI model and its more practical counterpart, the TCP/IP model. The OSI model is like the blueprint for a skyscraper. It's a detailed plan of how everything should function, but it's not the actual framework holding things up. That job falls to the TCP/IP model, which is what the internet really runs on. In the TCP/IP model, those top 3 OSI layers transform into one large application layer. Imagine it like turning your dining room, living room, and kitchen into one big open space. At the other end, the physical and data link layers combine to form the network access layer. For the CCNA exam, you need to be well versed in both models and understand how real-world protocols fit into those OSI layers. Imagine sending data across a network, like taking a road trip. Your journey begins at the top of the OSI model, moving down through each layer on the sender's side and then climbing back up on the receiver's side. As your data heads down the layers, it picks up a new jacket or header at each stop, and that's what's called encapsulation. At layer 4, your application data gets dressed up as a segment. By the time it reaches layer 3, it transforms into a packet. At layer 2, it's wearing a frame, and when it finally hits layer 1, it's down to just bits. When the data reaches its final destination, each layer peels off its respective jacket in reverse through a process called de-encapsulation, until the original data is ready to be used by the application. It's a little like unpacking your suitcase until you find that favorite shirt you're looking for. The age-old question, which OSI layer does your device call home? Let's break it down. Starting with layer 1, the physical layer, think of hubs and repeaters as the town criers of networking. They shout signals louder, but let's just say they're not winning any awards for intelligence. Jumping up to layer 2, the data link layer, we have switches and bridges. These guys are like bouncers at a club, checking MAC addresses to decide who gets through. Now at layer 3, the network layer, it's the routers and layer 3 switches taking charge. They're your GPS, using IP addresses to guide traffic on its way. And just when you think you've got it down, some switches do double duty at layer 2 and layer 3, earning the title of multi-layer switches. Keep this hierarchy in mind, and you'll be well prepared for the exam. Let's dive into 5 common OSI traps that can trip you up during the exam. First off, those layer numbers are key. They go from 1 to 7, starting at the bottom. So physical is layer 1 and application is layer 7. Next, the PDU names change as you climb the layers. Think of it like a mail parcel switching packaging at each post office stop. It's a segment at layer 4, a packet at layer 3, and a frame at layer 2. Now for switches. A regular switch is a layer 2 device, but when you hear about a layer 3 switch, it means it can also handle routing. Not just a marketing gimmick. The OSI model describes protocols, but in reality, it's the TCP/IP suite that's doing the heavy lifting. Lastly, SSL/TLS hangs out at layer 6, the presentation layer, not layer 7. Yes, it seems backwards, and this confuses everyone the first time. So keep these in mind, and you'll have a leg up. That's the OSI model, stacked up in its 7-layered splendor. You've got the PDU names down, the devices at each layer, and remember how encapsulation is basically the postal service for your data? If you're aiming to conquer a mountain of CCNA practice questions, check out Courseiva.com. Keep moving forward.